Welcome to your first motion tutorial. For this tutorial, we are going to solve an honors problem involving acceleration. And we're actually going to solve two problems here. And we're going to walk through how to set them up and solve them. So here we go. The first thing we do in any problem is identify what we know. So we see a few numbers here. Negative 8 meters per second squared, 36 meters. I see this keyword stop, which is giving me some useful information. And I have two unknowns. What is the initial speed and how long? So I'm going to write these down. I have 8 meters, negative, 8 meters per second squared, 36 meters, and I have two unknowns. So let's look. 8 meters per second squared, that is an acceleration. 36 meters is my x. The initial speed is unknown. That is my vi. And how long did it take? That's a time. And I also mentioned that this keyword stop gives us some information. And if he comes to a stop, I also know that his final speed is 0. So I identified what I know, and I kind of see that I have almost everything here. I have every variable we've dealt with so far this year. So I'm going to start by writing the first equation. And I can plug my numbers in. I have 0, I have vi, minus 8t. And I see right away that I cannot solve this. I have two unknowns, only one equation. So the way we need to solve two unknowns is we need two equations. So fortunately, I have another acceleration equation, which is x equals vit plus 1/2 at squared. So I'm going to plug my numbers in here. And I have vit plus 1/2 negative 8t squared. Now it's very important to note, in fact this is extremely important to note, that we cannot use this equation. We cannot use it. Don't do it. The reason we can't use it is because that equation focuses on non-accelerated motion. So it focuses on if something is moving at a constant speed, the same speed. You'll notice there's only one v in this equation. So is it your initial? Is it your final? Well, it's neither. It's the constant velocity. So because it's a constant velocity, we simply just can't use that equation. This equation only works if something is going a constant speed and not accelerating. So if there is any acceleration, that equation just does not work. So keep that in mind. All right. So we have two equations. We have two unknowns. And we're going to solve for one variable and then substitute it into the other equation. And the variable I'm going to solve for is vi. And the reason I'm solving for vi is because over here I have two t's, and one of the t's is a squared. So because of that, I don't want to solve for t because I don't want to have to plug in something twice. So I'm going to solve for vi. So right here I'm going to add 8t to both sides. And I get vi equals 8t. So now I'm going to take that and I'm going to substitute it in for vi. And like I said, you could solve for t, but then it's just going to make your life hard. I think this way is probably the easiest way. And so then I have 36 equals 8t times t. And I have plus 1/2 negative 8t squared. All right, so then I have 36. 8t times t is 8t squared. And I'm going to simplify the second half. Half of negative 8 is negative 4, and I still have this t squared. So I can keep going. 36 equals 4t squared. I am going to divide both sides by 4. And let's scroll down a little bit. So then I get 9 equals t squared. I can take the square root of both, and I get t equals 3 seconds. Now that I have that, that's one thing I know. So I know that t equals 3, but I also need to find out what vi is. So I'm going to plug this back up into t. So I have 8 times 3, which is the t value I just found, equals vi. So my initial speed, vi, equals 24 meters per second. And that's it. So basically, to recap, I'm writing down what I know. I can start with one equation or the other, but no matter which equation I start with, I realize one will not be enough because I have two unknowns. So I need both equations. After that, I plug my values in. I get down as far as I can, and then I just transfer over, I substitute, and go down. All right, let's look at one more example. This example has Meeps. Meeps is walking at 2 meters per second and accelerates at a rate of 2 meters per second also. How long would it take her to walk 24 meters? So I'm going to go through the same process. I'm going to identify what I know. I know 2 meters per second. 2 meters per second squared. I see a question there of how long and 24 meters. So let's see. I have 2 meters per second. 2 meters per second squared, how long, and 24 meters. So I wrote down what I know. If I need to, I can use the chart in the front of my notebook, and I would see that this is my starting velocity. This is my acceleration, because it's the squared. How long is a time, and 24 meters is a distance. So I look at what I know, and I can look up at my equations, and I can see the equation that's going to fit is this guy. And in this case, I don't need another equation. I only have one unknown. So one equation should do it. And I think I have everything I need. Let's see. I have 24 equals 2t plus 1/2 of 2 times t squared. All right, so I can see kind of what's happening here. This 1/2 and 2, whoops, this 1/2 and 2 cancel. And I'm going to, I kind of see something here. I see that I have a quadratic. And the reason I know I have a quadratic is because I have this squared, but I also have the t. So because I have a t squared and a t, I know I have a quadratic. And because I have a quadratic, I'm going to rewrite this. I'll go small steps. 24 equals t squared plus 2t. And I want to move that 24 over. So I'm going to subtract 24 from both sides. And I'm going to get 0 equals t squared plus 2t minus 24. All right. So there are two ways to solve this. We could either use the quadratic equation, which sometimes you have to, or we could factor it. If we can't factor it, then we'll have to use the quadratic equation. But if we can factor it, then a lot of times factoring is easier. So we have a t and a t. I see I have a plus sign and a minus sign, so I know I'm going to need a plus sign and a minus sign. And I'm looking for two numbers that multiply to be 24 and subtract to be 2. So 6 and 4 multiply to be 24. So I have a 6 and a 4, and I have to put them in these positions because 6 minus 4 will give me that positive 2 that I need. And so I know that this first term, in order for it to equal 0, t would equal negative 6. And for the second term to equal 0, t would have to equal 4. And because we're dealing with a time here, really this answer is not possible because we can't have a negative time. So actually 1 is only a real solution, and the other one is math, but it doesn't really have a physics or physical connection to it. So our answer is 4. We need to make sure we put the units, and we are done. All right, hope you enjoyed this video, and if you have any more questions, please, please, please feel free to ask me. Thank you very much.